Thank you, everyone. I'm Conrad Metcalfe. I want to welcome you today. I'm with the New York Building Performance Contractors Association. We are a 20-year-old nonprofit trade association working on behalf of our members, primarily energy efficiency contracting companies, building science consultants, energy efficiency geeks like myself, and some Energy Star raters still out there. So I want to welcome you to this second webinar in our series of 3 to promote the deployment of air source heat pumps. This series will be followed by a hands-on workshop where participants will get direct experience installing air source heat pumps. And so just a quick introduction to webinar 3, which will be held next Wednesday at this time, where we'll examine the most common installation errors uncovered during quality assurance inspections. And we'll also cover some key best practices for design, for equipment selection, for installation, control setup, other things like even helping homeowners understand how to use their equipment. That will be addressed next week in webinar 3. Then on Saturday, August 22nd, we'll be holding that full day workshop for HVAC installers. Very hands-on experience with installation protocols based on those common errors observed over time during QA inspections. As we mentioned last week, this event is limited to 8 participants, and I'm pretty sure we have way exceeded that. So we're working to arrange additional workshops, hands-on workshops, and we'll let you know very soon if you were one of the first 8 accepted registrants. And if your situation has changed somehow and you can't come for some reason, I hope you'll just let us know so we can offer your seat to someone else. I'll also mention that you really have to fill out that pre-training survey before you can be admitted to the hands-on workshop. These surveys are a requirement from NYSERDA, who's sponsoring this, and we have to report this information to NYSERDA. So I would ask that you all make sure you complete the pre-training surveys and the post-training surveys as well. Very important to further this goal that we're pushing here. So today we have to appreciate the efforts of Heatsmart Tompkins for allowing us to continue to deliver on this promise of clean energy. Brian Eden is on the call today, and I'd like to express my thanks to Brian and to his team for their ongoing efforts to promote clean energy in New York. I also want to mention that the first webinar, last week's webinar, is now available on the Heatsmart website in the workforce training section. You can Google Heatsmart Tompkins. That's how I always get there. Or you can go to solartompkins.org and select webinars. As I think you can see, we have Jon Harrod on the line today. He'll be our instructor. John's been on the leading edge of home performance for 20 years. He's the only home performance contractor in New York that has a PhD. Well, the only one I know of anyway. He is the owner and co-manager of Snug Planet, a full-service home performance contracting company based in Ithaca, New York, doing zero-energy homes and installing heat pumps and anything else that furthers the goal. So I'll be handing control over to John in just a minute, but I wanted to mention a few quick housekeeping points. We will be taking your time to answer the questions that you put into the QA section. You have that QA section at the bottom of your screen. We'll answer those questions towards the end of the webinar, but you can feel free to ask them throughout the webinar anytime. There will also be opportunities during John's presentation to share your thoughts in the chat window, and I would encourage you to participate, but of course, be polite, be diplomatic, whatever. I would also ask that you complete that post-webinar series today. We'll send that link out to attendees. We won't send it out today, but we will send it out soon along with John's slide deck. And let me see, I think since everyone knows where the nearest bathroom is, that's probably the end of housekeeping for today. I'd like to make Jon the host. I already did that actually. And I'm going to hand control over to Jon. Jon, are you at the ready? I can see you are.
I am ready. Yes, thank you, Conrad.
Very good, and I can hear you just fine, and I appreciate you being here.
Thanks. So today we're going to be talking about how air source heat pumps are an integral part of an energy efficient and comfortable home. Here in New York, we are really in the early stages of a statewide mobilization that is going to change the way that we use energy in our homes. And heat pumps are a big part of that. And I think this is a very exciting thing that we're doing. And I'm hoping that as you're watching this today, you'll get some ideas for how you might be part of this transformation. First, just starting out with a little bit about me. I went to school as a biologist and then became a home performance contractor in 2001. My initial focus was on envelope work. I encapsulated a lot of crawl spaces. I put a lot of cellulose into attics, and eventually started getting interested in deep energy retrofits. These are very ambitious projects where we would take all the siding off a home, wrap the home in a thick layer of rigid foam, and then put the siding back on. And this was a really a pivotal moment in my understanding of energy in homes. We did all this work to these houses under this grant that we got from NYSERDA. And at the end of the day, we only achieved 65, some cases 75% reduction in energy use. And this made me think there's got to be a better way. And that's when I started getting interested in electrification and in heat pumps, and recognizing the ability of heat pumps to really transform the way that energy is used in homes and the way that homes emit carbon. Recently, during the COVID pause, I was able to kind of revisit my my long sidelined interest in writing. So I've been doing more and more writing about heat pumps and electrification. When we send out the slides for this webinar, I'll also share an article that I recently had in Building Performance Journal. And so I hope to continue to be doing more of that over the next couple months. The goals of this training are to get you familiar with some of the efficiency metrics that we use when we're talking about cold climate heat pumps, to look at the role of building efficiency, and particularly the building envelope, in helping to make heat pumps work well, to become familiar with some of the very generous incentives that are now available for cold climate heat pumps in our state, and to look at the training resources and certifications that are available for people that are interested in moving into this area. So starting with kind of the big why of why this is so important and why we're doing this. The burning of fossil fuels, whether they're coal, oil, natural gas, has released carbon dioxide into the atmosphere. Now, we need some carbon dioxide to prevent the Earth from becoming a frozen wasteland, but we've been putting a lot more into the atmosphere than has been there historically. And so over the last couple hundred years, we've increased from under 300 parts per million to now upwards of 400 parts per million. This chart is a couple years old, and our carbon dioxide numbers are now in the mid 14. So we are literally off this chart. Carbon dioxide is a heat trapping gas, and as a result of these increases, the temperature of the Earth has increased about 2 degrees Fahrenheit since the Industrial Revolution. And so we can look at the impacts of that temperature increase, but it goes beyond that. These increases in temperature are leading to all kinds of climate disruption. This photo is from Johnson City. This is the floods following Tropical Storm Lee in 2011. And so we're seeing a lot of local impacts, whether they're this kind of flooding or coastal flooding like we saw with Hurricane Sandy, an increase in extreme storms, an increase in hot summers. And these have real impacts on not just other places, but right here in New York State. New York State and NYSERDA have taken a very active role in trying to address New York State's carbon dioxide emissions. They've laid out the Climate Leadership and Community Protection Act, which is a multi-decade plan to get us to deep reductions in carbon dioxide. Starting now, NYSERDA is putting a lot of investment into creating green energy jobs in the efficiency and the renewable energy sector. They're looking to rapidly scale up distributed solar. You'll probably, as you're driving around parts of the state, see more and more of these community solar farms popping up. They're also making a big investment in offshore wind. So that our goal is by 2040 to get to 100% clean, renewable electricity. And by 2050 to get to an 85% reduction in greenhouse gases relative to the 1990 baseline. So where does work in buildings fit into this goal? Right now, about 30% of the emissions in our state are from on-site combustion of natural gas, oil, propane in buildings, and that includes commercial buildings, residential, and industrial. As long as those buildings continue to burn fossil fuels, they're going to keep emitting carbon dioxide. So our goal is to transition them away from fossil fuels and onto electric heat generated by heat pumps and ultimately powered by renewable electricity. So this represents kind of a three-pronged approach. We are taking steps to improve efficiency, so to reduce the demand for heating. We want to replace that fossil fuel equipment with energy efficient heat pumps. And then we want to power those with electricity from a renewable grid. This is an essay that has been widely read in the environmental community, and I think is one that's worth checking out, by David Roberts, who wrote in Vox. His essay was titled Electrify Everything, and it really kind of crystallized for a lot of people the importance of switching entirely away from fossil fuels to an all-electric economy for both buildings and transportation. And a point that he made really clearly that really kind of echoed my own findings with the deep energy retrofits is that a gas furnace's rate of carbon emissions is essentially fixed for its lifespan. So that when we install a fossil fuel furnace, we're essentially locked into 20 years of carbon dioxide emissions. Now, we know from climate science that we don't have 20 years to start addressing these issues. So every new gas furnace that's installed is essentially a step backwards in our attempts to address the climate crisis. Now, the cool thing about electrification is that even though our current electric mix isn't 100% renewable, over time it's becoming greener and greener. And even if we switch to heat pumps today, we achieve dramatic reductions in carbon emissions. But that grid is going to keep getting greener over time, so that ultimately we are able to, with the heat pumps that are installed today, gradually get to zero emissions. There are heat pumps for just about every residential application. A lot of attention has been given to ground source heat pumps, geothermal, and these are really terrific. They are expensive and they're not suitable for every household. And so I've decided instead to focus on air source heat pumps. And I find that those are, although they're perhaps not as efficient in all ways as geothermal, they're a lot more scalable. So that's what I'm going to be focusing on today. And then there's also heat pump water heaters, which are a great entry point for people that are looking to begin electrification. You can replace a fossil fuel water heater at modest cost and begin that path towards electrification. This is a graphic that I really like. It was created by Cornell Cooperative Extension and Get Your Greenback Tompkins, and it explains in a simple way the way that cold climate air source heat pumps work. There's a refrigerant that cycles in between the outdoor unit and the indoor unit, and it's got two devices, an expansion valve and a compressor. The expansion valve drops the pressure of the refrigerant to a very low point. And when it drops the pressure, it allows that refrigerant to boil at very cold temperature. So it can absorb heat from very cold air, even well below 0 degrees Fahrenheit. The compressor squeezes that gas into a much smaller volume, and in the process raises its temperature. The refrigerant circles into the house and reaches the indoor heat exchanger, and now it's able to release the heat that it absorbed outdoors. And so it travels around and around each time, absorbing heat outside, releasing heat inside. Now, heat pumps have what's called a reversing valve, so that in the summer, when you want cooling, you can reverse the cycle and then absorb the heat inside and reject it to the outdoors. So they can provide very efficient heating and cooling. We're going to be talking about heat pump efficiencies, and I just wanted to give a little bit of background as to some of the units of energy that we'll be discussing. Watt is a measure of instantaneous power. It's how much a device is using at any moment in time. So we can think about a 60-watt light bulb or a 1,000-watt heater. At any moment in time, those are drawing 60 watts or 1,000 watts. How long they're used determines how much energy they ultimately consume. And that's where watt hours and kilowatt hours come into play. Our electric bills are based on our kilowatt hours of usage. Now in the US, kilowatt hour is typically used to measure electrical energy, but kilowatt hour can also be used as a measure of heat or thermal energy. And in fact, in Europe, a lot of heating equipment is rated by its kilowatt output rather than its BTU output. Here in the US, the heating output of furnaces, boilers, and heat pumps is largely described using BTUs, which are British thermal units. This is the amount of heat that's needed to heat 1 pound of water 1 degree Fahrenheit. And a typical house might need somewhere between 25 and say 80,000 BTUs under very cold conditions to maintain a steady temperature. All these units can be interconverted. A kilowatt hour of electricity represents 1,000 watt hours, and that also represents 3,412 BTUs worth of heat. When we talk about the efficiencies of heat pumps, these are a couple of the different measures that are going to be used. I like coefficient of performance because it is just a simple ratio of heat output divided by heat input. And you can think about it in BTUs produced per BTUs of electricity consumed, or kilowatt hours of heat per kilowatt hours of electricity. Electric space heaters produce 1 BTU of electricity, one BTU of heat for each BTU of electricity you put into it. So they're essentially 100% efficient at turning electricity into heat. But heat pumps, through this refrigeration cycle, are able to achieve much higher coefficients of performance. How efficient they are is going to vary with the outdoor temperature. The colder it is, the harder they have to work to extract that heat. But heat pumps are typically able to extract anywhere between 2 and sometimes more than 4 units of heat energy for each unit of electrical energy that you put in. So they're 200 to 400+% efficient. As we think about how we can rapidly get our housing stock off of fossil fuels, this efficiency is really key. And it's also key to keeping people's costs down. We all know that electric resistance heat can get very expensive, but heat pumps can cut those costs by a half or 2/3 in many cases. Other ratings that you're likely to see when you're looking at heat pumps are the HSPF, the heating season performance factor. This is a slightly different measure. It's measured in BTUs per watt hour, and it doesn't represent an instantaneous measure of heat. It is averaged over a heating season under certain standard conditions. And the seasonal energy efficiency ratio, that's a measure of cooling. It's also measured in BTUs per watt hour, but it reflects seasonal cooling efficiency, representing the fact that you're going to experience different conditions over the course of a cooling season, and the system's going to be more efficient under certain conditions than others. One thing that I often talk to customers about is the fact that modern heat pumps are nothing like the heat pumps you may have been used to if you were in the South or the Mid-Atlantic 20 or 30 years ago. These older heat pumps were often very loud. They dropped dramatically in their performance when you got below about 40 degrees, and switched over to either a backup furnace or a electric strip heater, so that people were often used to low levels of comfort and high energy bills with these old heat pumps. Modern heat pumps are a lot more efficient. The Northeast Energy Efficiency Partnership, NEEP, has created an excellent set of resources for cold climate heat pumps. And they've also set criteria for what gets to be called a cold climate heat pump, which NYSERDA has used as its criteria for the incentives that are offered. To make it onto the cold climate heat pump list, you have to have a variable capacity compressor. And we're going to talk a little bit more about what that does and why it's important. The indoor and outdoor components have to be from an AHRI match system, meaning they have to be engineered to work together. You're not able to mix and match the way you are with some older heat pumps and air conditioners. These are really, if you have a Mitsubishi outdoor unit, you're typically going to be using a Mitsubishi indoor unit, and the same thing for other manufacturers. And so the indoor and the outdoor unit are matched very closely and are designed to work well together. Now, the performance criteria for a cold climate heat pump, they have to be able to have a COP of 1.75 or better at 5 degrees Fahrenheit. So that means that when the temperatures are down in the single digits, which is quite rare for most of the state, they are still producing almost 2 units of heat for each unit of electricity you're putting in. So we don't see that same kind of drop off in performance that we saw with the old heat pumps. They are still almost twice as efficient as electric resistance heat at very cold temperatures. Their seasonal efficiency, represented by the HSPF, the heating season performance factor, also has to be high. It's set at 10 for ductless systems. A HSPF of 10 translates into an average coefficient of performance of about 2.9 over the entire heating season. So what that means is that over the entire range of conditions that you're going to experience throughout a heating season, you're going to be almost 3 times more efficient than electric resistance heat. And they also have very high cooling efficiencies. A lot of older air conditioners might have SEER ratings of 10 or lower. Modern air conditioners are a lot better, but cold climate heat pumps are also very efficient in cooling mode. You can visit the NEEP cold climate air source heat pump list and take a look at some of the specs for different units. It will tell you information like what is its output at 5 degrees Fahrenheit and what is its coefficient of performance at 5 degrees Fahrenheit. And so this is a great resource if you're looking to become more familiar with these units or to pick ones that are suitable for your project. One of the criteria on the NEEP list is a variable capacity compressor. And this is really a big part of how these systems get their very high efficiency and their good performance in very cold weather. Conventional heat pumps were like a car in which you could only stomp the pedal to the floor or take your foot off it entirely. And so as a result, the way that they work is that they heat the house until the thermostat is satisfied, they overshoot, and then they shut off. Take the foot off the gas, temperature drops until it's below the thermostat set point, they kick back on again. And so this leads to temperature swings. It also is not ideal from an efficiency perspective because the system is either running flat out or not running at all. Variable capacity heat pumps, they're sometimes referred to as inverter driven because they have a electronic device called an inverter that changes the alternating current electricity into direct current electricity. Essentially, that allows them to run their compressors at a continuous range of speeds. So when they're looking to rapidly bring the temperature in a house up, they can ramp up to a very high speed. They can, go into turbo mode. But then once they reach their desired temperature, they can throttle back. And by doing this, you can achieve much more even temperatures. And you can also keep the heat pump running in the middle of its capacity range, which is where it's a lot more efficient. In order to get this kind of excellent performance and even temperatures, there are some things that you need to be careful of during the design and installation process. And we're going to be talking about those more in the next webinar. This graph is for a Mitsubishi heat pump, and it just shows the contrast between an old style standard heat pump whose performance drops off dramatically as you get below about 30 or 40 degrees, and a modern cold climate heat pump that maintains its full output all the way down to single digits, and even at very cold temperatures, like -13 Fahrenheit, is still performing at a good percentage of its rated capacity. What people are most familiar with are, in terms of cold climate heat pumps, are these ductless heat pumps, or sometimes they're referred to as mini splits that have an outdoor unit and one or more of these indoor high wall heads. But that's just a small portion of the range of options that are available today. We have not only multiple types of high wall heads in different colors and styles, but we also have ceiling cassettes. There are indoor units that are hidden within picture frames. There are also these compact ducted units. The lower two in the middle are compact ducted units that are essentially mini air handlers that can be used to supply heating and cooling to small rooms, maybe a suite of rooms with no devices on the interior walls. And one of the things that I find most exciting, and I think is going to really help this scale, is that these cold climate heat pumps now have full-sized air handlers that are, in many cases, suitable to be swapped out directly for a forced air, natural gas, or oil or propane furnace. And so this way we can, provide central heating and cooling, fully ducted. Usually there's some calculation and some duct modification that needs to take place to get those to work well. Just to mention briefly some of the social benefits that are associated with electrification and cold climate heat pumps. Cleaner air, both inside and out. We're eliminating carbon dioxide from the emissions. We're also eliminating carbon monoxide from improperly operating heating equipment. So we're eliminating a big source of indoor air quality issues. We're also getting rid of natural gas. Just recently, this last week, there was an explosion, I believe it was in Baltimore, that leveled a couple homes, and you'll hear about those periodically in the news. One more reason to get natural gas out of homes. They provide very high efficiency cooling, as we described. Because they're so efficient, they can really reduce energy costs for low and moderate income households. And this issue of energy affordability becomes a big part of social justice and poverty alleviation. It is especially true when we're replacing expensive fuels like electric resistance or oil or propane. And, you know, a big part of this push too is the benefit of supporting local living wage jobs. And as we're going to see, this is going to take a major mobilization, and there's going to be a lot of need and a lot of opportunity for people that are interested in moving into this field. I'm assuming that there are a lot of people on this call who are business owners or contractors. There's a huge business opportunity to be had here. Right now, we have over a third of the state who heat with those expensive fuels, oil, propane, electric resistance. That's 1.75 million households. We have another 3.3 million households who are either cooling with noisy and inefficient window units or have no air conditioning at all. And most of the heating equipment in homes in our state is going to require replacement in the next 15 or 20 years. And so there's an opportunity every time one of those systems ages out to be replaced with high efficiency heat pumps. There are some really great incentives available, and we're going to be talking about those next. Those are what make it affordable and possible to build some of these bigger work scopes that allow people to fully electrify. Right now, the New York State clean heat incentives are available throughout the state. They are administered by the utilities, and they provide really great incentives. For whole house solutions with air source heat pumps, they provide $1,000 per 10,000 BTUs of heat delivered at 5 degrees Fahrenheit. So if you're putting in a, it might be a pretty typical whole house system, it might be 42,000 BTUs at 5 degrees. So that's a $4,200 incentive that can be taken off the cost of the project. These utility incentives can be combined with NYSERDA residential programs. NYSERDA continues to offer no-cost home assessments. So it's a great way to get the building shell and the mechanical equipment in your home evaluated. And we'll talk a little bit about that in just a moment, about how that can help to move you along the path towards high efficiency heating and cooling. There are also assisted home performance grants. These are matching grants. They're targeted at households that historically was targeted at low and moderate income households. It's recently been expanded to 120% of the area median. So what that means is that more than half the people in the state meet the income guidelines for these grants, and they provide up to $5,000 of matching money to upgrade your efficiency. There are also low interest financing that is available to households of all income levels. The credit requirements are fairly relaxed, and they provide interest rates anywhere from 3.5% to 7.5% with 15-year terms. So when you start to stack these different grants and incentives and financing together, you can bring this package down to a very affordable monthly payment. Another pilot program that I just wanted to mention briefly is the Comfort Home program. This is designed to encourage people who are considering heat pumps to start by doing the insulation and air leakage reduction work that is going to help those heat pumps work better and perform better in the long run. This is not available statewide. It's being offered on a county by county basis. But if you are in one of the pilot areas, you can offer your customers up to $6,000 for comprehensive work scopes that reduce the heating needs of the house and then include heat pumps. Another group, or another set of groups that I think is really worthy of a shout out is the Heatsmart communities. This presentation is being sponsored by Heatsmart Tompkins, which was one of the first Heatsmart communities, but now there are Heatsmart communities cropping up in many regions in the state. And these are largely volunteer efforts that are out to educate the public about the importance of electrification and heat pumps. They host community meetings, open houses, and at least some of these Heatsmart communities are offering additional grants that can be stacked with the other funding sources that we just discussed for low and moderate income households. I know that Heatsmart Tompkins is offering an extra $2,000 per household if you're a low income household and you're installing a heat pump, another $300 if you're also installing a heat pump water heater. And Heatsmart CNY, which handles Syracuse and surrounding region, they're offering similar incentives. I was just in contact with someone from Heatsmart Southern Tier. It sounds like they're moving in that direction as well. And if people are aware of any of those other Heatsmart communities that are offering these kind of grants, it would be great if you could just put those in the chat. Now, if you're a business that is looking to pursue this direction, there are some more resources that are available. NYSERDA PON, it stands for Program Opportunity Notice, is available. It provides marketing co-op funds, so it will provide a 50% cost match for certain eligible marketing and advertising efforts. They will also offer 50% reimbursement for certain sales design and installation training. So those are worth looking into. NYSERDA offers on-the-job training funds. These provide, for smaller companies, they'll provide 50% of a new hire's wages for the first, I believe it's the first 8 weeks. And so this is a great way to buy down the cost of bringing a new person into your company during that time when they're just learning and they're not going to be as productive as they will once they're fully trained. There are also clean energy internships. So if you're interested in hiring a college student either over the summer or during the school year to help with your efforts, NYSERDA provides internship funding there. So there's lots of different funding sources, and learning how to navigate these is a way that you can really help build your business. Now, for the challenge. If we're really going to get every household in New York State off of fossil fuels, that's 5 million households over the next 20 years. And what that translates into is roughly 700 heat pump installations per day, no weekends. So we just have to start to think about what is it really going to take to scale up our industry to achieve this. Yes, the opportunity is huge, but there are some real challenges. Where are we going to find the workforce to do this? How are we going to train them? How are we going to make sure that we've got a flow of capital that's going to help our businesses grow? How are we going to create the business systems that are going to allow us to do this in an efficient and profitable way? And as we're rapidly scaling up and bringing new people and learning new skills, how are we going to make sure that the quality stays where it needs to be so that customers are happy with our work and we really do achieve the environmental benefits that we're going after? One of the things, and I just wanted to share this because I found it extremely useful in my own life, is this whole idea of accelerated learning. There have been some essays out there that have talked about, it takes 10,000 hours to become really good at something. And, I think, if you want to become a Simone Biles level gymnast or Yo-Yo Ma on the cello, yes, that's the level of investment that you're talking about. If you want to become a well-rounded and experienced HVAC installer, 10,000 hours is about what it's going to take. But we can achieve competency in well-defined tasks a lot faster. And if we need to do this, there are some processes that can really help you learn the skills that you need a lot more quickly than you might think. This idea was taken directly from some work by Josh Kaufman. You'll find him all over YouTube as well as in his book. But essentially, the key to rapidly acquiring a new skill is to first define what your target performance level is. And that needs to be a discrete, well-defined task. You would not set as your target performance level, I want to be an expert HVAC installer. You might set as your target performance level, I want to be able to install a single zone ductless heat pump according to best practices, start to finish. So it's a really well-defined skill that you're going for. And then you break it down into component tasks and define each of those. And you focus your training on those individual tasks, each of which is a small bite of the big picture. But when you've mastered all of those, you've mastered the skill. And then the next pieces are removing barriers to practice. So making sure that your practice time is fully committed. Your phone is silenced, you're not drifting onto the internet or being distracted by other things. So really make sure that your time is focused. And really key is pre-committing, making that commitment, because the first few hours are going to be confusing and frustrating. But if you pre-commit to investing 20 hours, whether it's over the course of a couple weekends or an hour a night, you will be surprised what you can accomplish. So this is an example of our target performance level would be to install a single zone heat pump. Our component tasks are things like hanging the indoor unit. And within each of those, there are specific skills. We need to know what is the suitable location. We need to locate the studs so that our piping our holes for our piping don't hit the studs. We need to know how to secure the mounting bracket accordingly. And the same thing, you can break this down. I think for a single zone heat pump, I'm at around 15 component tasks, each of which have some subtasks. But you can see each of these things are skills that can be learned and drilled and practiced. And I think that's breaking things down in this way is going to help us get where we need to be. Another piece that I think is going to help us rapidly scale is increased use of checklists. There's a great book that I didn't include here, but it's really well worth reading by a surgeon named Atul Gawande called Checklist Manifesto. And his point was that a lot of avoidable errors can be achieved by using good checklists. If a checklist includes every single task, people aren't going to use it because it wastes their time. But if you focus your checklists on the specific deficiencies, the specific errors that you're trying to correct, they can be an incredibly useful tool. So NYSERDA currently asks us to fill out this air source heat pump commissioning checklist. And using these consistently and effectively, I think, is a big part of not only helping us achieve good results, but achieve that quality management piece as well. When we look at some of the different competencies that we're going to need, sales and design is a huge one. There's a lot of learning that needs to take place here. And it's really a interdisciplinary skill set. There are skills of building analysis, so evaluating the building envelope, like our energy auditor here. She's got a blower door to measure air leakage. She's got a thermal scanner, which can help pinpoint the air leakage. It can also help determine wall insulation levels. You need to be able to evaluate the electrical system to determine, do you have sufficient capacity or do you need a service upgrade? And you also need some ability to evaluate the existing HVAC system. Do we have enough ductwork to achieve the higher airflows that you're going to need with a cold climate heat pump? There's load calculation, which we'll talk about more in the next couple slides, but that's figuring out how big a heat pump you need. And there's a set of software and methods that you need to use to do that. Really getting familiar with the equipment so that you can select and specify the correct equipment for the job. There are great tools like the one pictured on the upper left here, which is the Mitsubishi software called Diamond Systems Builder. Allows you to build a system with drag and drop software, and it'll tell you exactly, how much refrigerant you need to add, how many BTUs you're going to get out of it, given the specific combination of equipment that you're using. And then there's a lot of nuances to knowing how to locate and zone a system. And we're going to be talking about this more in the next webinar and also in the field training. And then customer communication is really key, helping to explain to people how heat pumps are going to be different than the heating systems they're used to, and also how to use them for their maximum benefit. Sales and design person really needs to be familiar with the house as a system concept. This typically starts with a comprehensive home assessment or energy audit, but you really want to be able to recognize the unique characteristics of each house and understand how changing one thing may impact others. If we take the old boiler out of the basement and replace it with ductless heat pumps, suddenly you no longer have that heat source in your basement. Moisture issues that you didn't know about before may start to show up. And there's things like that, having a good understanding of the way that the different components of the home and the occupants all interact together is really important. Building envelope, having a good building envelope makes heat pumps go a lot better. Although we no longer are advocating going to the extremes of the deep energy retrofit, we want to make sure that we're doing the simple, straightforward stuff that can be accomplished in a couple days. We want to make sure that the attic is well sealed and well insulated. If the walls are empty, those absolutely ought to be filled with insulation. And then we find that the basement, and particularly unfinished basements, are places where there's a lot of opportunity to spray foam the walls, to spray foam the rim joist. And so by doing this kind of fairly basic but affordable stuff, you can make the house more comfortable and bring their heating requirements down. The information you gather about the building shell goes into your heating and cooling load calculation. So it's called your manual J calculation that determines how many BTUs of heating and cooling you're going to need. This is a screenshot from one of the tools that we use for that called RightSoft, and it gives you, this is a big old farmhouse, but it does show you where a lot of the heat losses and heat gains are coming from. In this house, more than half the heat loss was coming from air leakage, infiltration. And so getting that under control is going to help us to make that house a lot easier to heat. Most of the heat gains in the summertime were coming from windows, and short of replacing windows, which can be a very expensive measure, there's not a lot we can do about that. Things like wall and infiltration factor in a lot less in cooling loads. Now, the information on both the heating and the cooling loads goes into our equipment selection. In our climate, heating loads are almost always larger. They're often twice or more than the cooling loads. Moving on to the install phase, some of the competencies that the installer is going to need. A lot of it is essentially carpentry and site work. You're hanging an indoor unit. You are setting an outdoor unit on a pad. You're assembling a stand. You are attaching these line set covers neatly to the house. There's an electrical component. You need to be able to run a new circuit from the breaker panel out to your unit, or you need to bring an electrician to do that. And then the kind of HVAC specific skills involve working with refrigerant piping, knowing how to properly evacuate and charge a system with refrigerant, knowing how to make sure it's free of leaks, and then testing it to make sure that it's doing what it's supposed to do and producing the correct number of BTUs in heating and cooling mode. During the last webinar, someone had asked about what tools are you going to need for this kind of work. This is a nice slide that I got from an LG training I was at. This gives you most of the tools that you're going to need. You're going to need pressure gauges. You're going to need a core remover, which helps you access the refrigerant side of the system, a flaring tool to make your piping connections, refrigerant scale, micron gauge, electric meter, and a vacuum pump. There's a couple of things that aren't listed on here that you're going to need as well. You're going to need a refrigerant recovery machine. And I also like to have some thermohygrometers for measuring things like wet bulb and dry bulb temperatures. But all in, you're looking at a pretty substantial investment in equipment. In addition to basic hand tools and things like ladders, you're looking at an investment of $3,000 to $5,000 worth of equipment to really do this right. Now, as we install more and more of these systems, service is going to become a bigger and bigger part. Right now, we're in this kind of honeymoon phase when we're installing all these systems. Most of them are less than 3 years old, and so service hasn't become as big a thing. But as these systems age, it's going to be really important to be able to service these and keep them running well so that people remain happy and it doesn't damage our efforts. A lot of the tools in the service side of things involve just being comfortable assembling and reassembling these items and giving them a real thorough cleaning. But there are some pretty sophisticated diagnostics and troubleshooting skills. You need to be able to work your way through a troubleshooting diagram to test voltages at different points, to handle refrigerant comfortably, to measure airflow. And you also need to be able to talk to occupants about the things that they're doing that might be preventing them from getting the results they're looking for. And then, as a field guy, I tend to focus a lot on the field skills, but there's a business systems piece of this that is really huge. We need to have the systems in place to schedule and execute on preventive maintenance and emergency service. As we're working with these incentives, we need to have good paperwork in place so that these get submitted in a timely manner. We need to be able to process the warranties, and we need to be able to recruit and train the workforce that's going to do this. We also need to have robust systems in place so that we're assuring quality installs for all our customers. I wanted to just talk briefly about a couple of the entry points for people that might be thinking about moving into this line of work. If you're a NYSERDA envelope contractor, you're doing low income work through Empower New York or assisted home performance, you already have a whole house mindset. You're already comfortable with energy modeling, using software tools to calculate energy use. It's not a big jump from calculating annual energy savings to calculating peak heating and cooling loads during the coldest hours of the year. You probably are also coming into this with some basic electrical and carpentry skills. You've changed windows or doors, you've wired up bath fans. So you already have a lot of these skills, and you know a lot about shuffling paperwork if you work with the NYSERDA programs. The places that you're going to need to build your skills are everything related to mechanical HVAC equipment. You're going to need to change your business model from kind of the once and done model that we have with insulation and air sealing improvements to the customer for life model, where you are, you know, building both the profit and the business systems to be able to go back and serve this customer on an ongoing basis. You want them to not only hire you to install this piece of equipment, but the rest of the equipment that they're going to buy for their time in the home. And you have to get used to setting up on-call and after-hour service, which is something we don't usually think about in installation. Now, if you're a non-NYSERDA contractor who does HVAC or plumbing or electrical, you're coming in with a different skill set. You've got a lot of experience with different aspects of the mechanical work. You're probably used to this customer for life model. You may have on-call and after-hours capacity already, and you probably, you know, have a pretty good handle on basic electrical and carpentry work. The places where you may need to grow are in developing that whole house mindset. Some HVAC contractors are used to thinking about the way that the building envelope impacts their system design, and some aren't. You're going to have to become a lot more familiar with energy modeling, and you may need to get some additional training with advanced cold climate heat pumps, which are a little bit different than the conventional AC and heat pumps that you're used to working with. If you haven't worked in the NYSERDA programs before, learning how to process these incentives is probably going to be the heaviest lift that you've got. And then if you're an individual, whether you're you know, a recent grad or someone who's looking for a career change, what are your entry points to this heat pump revolution? There are some, and I just wanted to put these out there. If this is something that's of interest to you, don't hesitate to drop me an email, and I will see what I can do to help you on your path. Getting involved, if you don't have basic construction skills, getting involved in a community build project like Habitat for Humanity is a great way to get those started. Trade school, and we're going to list some of the available trade programs on the next couple slides, can be a great way to start to, you know, get a pretty robust set of training. There are also formal and informal apprenticeships that can help you move into this, you know, starting as a helper level and eventually moving into installer and service capabilities. But that's a multi-year journey. The on-the-job training grants that we talked about can help, and if that's something that you want to bring to the attention of a prospective employer, I think they'd probably appreciate that if they're already participating in NYSERDA programs. And both NYSERDA and the Heatsmart communities are looking to promote more and more workforce development, like this webinar series, but there are many other educational opportunities that are available. Just to look at some of the places you can think about for training, a lot of the community colleges and a couple of the SUNYs have HVAC training programs. A lot of them are you know, either you know, multi-month programs or associate degrees. There are some really great regional training centers. The ones that I am familiar with that do heat pump related work are downstate, the Association for Energy Affordability and the Green Jobs Training Center. Both of those are in the city. The Green Jobs Training Center is where I got my BPI heat pump certification. The manufacturers are very eager to train, and these typically are hosted by local distributors, but bringing in a rep from a manufacturer like Mitsubishi or LG and providing really high quality trainings. The NYSERDA clean heat programs, if you are a person who's learns well from online sources, there are just some amazing resources that are out there. And I just listed a few that I've gotten a lot out of. The Energy Vanguard blog is a great way to learn about some of the design and whole house thinking that goes into these systems. Same thing with Green Building Advisor. It has a lot of discussion of cold climate heat pumps. And if you're looking to begin your journey in terms of becoming an HVAC installer or service tech, HVACerschool.com is a amazing resource. It's linked to an excellent YouTube channel, and I've gotten a lot out of those resources. Some of the certifications that you may want to think about, one that you're going to need if you are touching the refrigerant side of any of these systems, either as an installer or a service tech, is your EPA. Section 608 of the Clean Air Act, which was originally designed to protect the ozone layer, basically gives you the rules for proper handling and recovery of refrigerants. And that's a course and a test and a certification that you will need to enter this field. The Building Performance Institute is the organization that credentials home energy auditors, building analysts, and multifamily building analysts. It also offers a air conditioning and heat pump professional training, and that's another way that you can. It's required to participate in some of the NYSERDA programs, not all of them. And then as you advance in HVAC, the National Association of Technical Excellence, or maybe I think I might have got this wrong, it might be Technician Excellence, offers advanced certifications for HVAC installers. So we're just about done here. We are going to be having one final webinar in this series next week at the same time. It's about how to install air source heat pumps without callbacks. And I will tell you that I paid pretty dearly for a lot of the information I'm going to be presenting. In terms of mistakes that I've made, some I've read about. Heat pumps can be awesome, but in order for them to achieve their potential, they really, they're not very forgiving in terms of poor design and poor workmanship. And they are possible to get right. And that's a lot of what we're going to be talking about in the next webinar. And I would say go ahead and register for that. We are going to be offering a one-day hands-on workshop. This is on August 22nd. And we are actually going to install an air source heat pump start to finish. Because I wanted this to be very hands-on, I had to limit the class size to 8 attendees. So if you haven't already registered for that, please go ahead and do so. If the course is filled up, we are going to try to get some additional funding to continue to offer this on an ongoing basis. We'll just need to, we need to get a grant to do that, and then our goal is to develop a mobile training rig that we can use in different areas of the state. But that's a 6-hour class. It's going to be here in Ithaca, New York, and I'm hoping that it's going to be just a great class for everyone. With that, I am going to wrap it up and open things up to questions.
Very good. Thank you so much, John. Good job. We do have a number of questions that I'd like to bring, and everyone out there can feel free to add more as they come in. You did mention the reversal valve, and the question is this something that the homeowner has to do? Do you have to switch that valve as a homeowner to switch it from summer to winter?
No, you don't. The most that you would need to do as a homeowner is shift your controller or your thermostat from heat to cool. Okay. And that's generally what we recommend. Some heat pumps do have what's called an auto mode, which allows the thermostat to switch automatically from heating to cooling, but that can sometimes lead to some, unexpected behavior. So everything that the homeowner needs to do is from the thermostat or the remote control.
Ah, very good. Okay. Compare the current cold climate heat pumps with conventional air conditioners. What's it look like in terms of efficiencies?
Yeah. So here we're comparing efficiency strictly in cooling mode. Conventional air conditioners, I actually don't do a lot of those, so I can't speak with perfect knowledge about what the full range of efficiencies are. But the ones that we've been seeing lately have SEER ratings of the 13 to 16 range, maybe a little bit higher. And air source heat pumps can achieve much higher SEER ratings. Some of those are 20, some even 30 and up. The nature of the SEER rating is that it's one of those things like miles per gallon for a car. It's based on very specific set of test conditions, and your mileage may vary. A lot of manufacturers seem to have certain tricks for gaming these SEER ratings to get those very high numbers. Invariably, there seems to be a trade-off between higher SEERs and better dehumidification. If you slow your indoor fan down to the point where you can really pull a lot of moisture out of the air, it's going to hurt your SEER rating. So I would say that it's worth looking at these kind of ratings, but it's also worth talking to your contractor about your specific goals with this application and how much dehumidification, what are your target indoor temperatures, and based on those kind of conversations, you'll be able to select the equipment that gives you the result that you're looking for.
Ah, very good. Good answer. Is water a better heat transfer medium than air? What do you think?
I think that's a really that's a multifaceted question. I think that water being a denser medium can carry a lot more heat per unit volume, and so that's why we have our boilers piped with 3/4 inch piping and our forced air systems with 6-inch diameter ducts. The kind of exchange that you get between a groundwater or a geothermal heat pump and the water that it's interacting with is extremely efficient. And you're also taking advantage of the fact that the ground temperatures are a lot more constant than the air temperatures. The challenge with water-based heating and cooling systems is that you really can't cool with hydronic systems in residential. There are ways to do it in very dry climates, but anytime you make a surface cold in a green grass climate like the Northeast, you risk condensation. And that's why cooling in residences is always done with forced air.
That makes perfect sense. How can we make sure that the ductwork we install is properly sized for both heating and cooling? Ductwork is typically sized for heating, for cooling, but that may be different for heating. How would you comment?
Yeah. When we're installing a ducted heat pump, we need to look at the manufacturer's airflow requirements. And the old rule of thumb was we need 400 CFM per ton of cooling, or 400 CFM per 12,000 BTUs. The manufacturer's equipment doesn't always follow that rule exactly. And so sometimes it's a little more, a little less. Actually, heat pumps tend to be a little bit less than conventional air conditioners. We also have this issue of the fact that our heating load is typically twice what our cooling load is, and different parts of the house require different amounts of heating relative to cooling.
Right, like a kitchen in the summer would require more cooling than in the winter.
Exactly. So there's no perfect answer to this. If you're using the same distribution system, you know, some of the solutions that have been come up with are zoning. You can use zone dampers, but in my experience, really the critical thing is getting a good building envelope, because the better the insulation and air sealing, the more even the temperatures tend to be within the house, and the easier it is to maintain comfort throughout. Yeah, there is really, you know, no perfect solution for that question. Ductless systems, that's a place where they can kind of shine, actually, because say you have a house that has multiple ductless systems, or even multiple compact ducted systems in each part of the house. Each of those is responding individually to the demands of the room that it's in, and that problem can be solved that way.
Mm-hmm. Okay, yeah, very good. Many people are talking these days with coronavirus about air filtration. What advice might you give regarding equipment and operation to minimize health issues, especially during this current pandemic?
Yeah, this is something I think that's been on our mind a whole lot recently. You know, the guidelines for preventing coronavirus transmission are really things that make sense for indoor air quality anyway. Fresh air ventilation, humidity control, and high MERV filtration. In order to achieve those things, we typically are building a system, and a ducted heat pump can include a high MERV filter for sure. You will need another device to bring in some fresh air ventilation, and you may also need a dehumidifier during certain times of the year to keep that humidity in the desired range. In the summer, your cooling is going to be dehumidifying, but during the shoulder seasons, with the current heat pumps we have, they don't do a good job of kind of shoulder season dehumidification.
Right. Yeah, I agree. Yeah, we talked last week about systems that are using ultraviolet radiation to clean air, and those systems are out there. I think
Yeah,
that's what you said.
I meant to include a link, but there actually are UV lights that can be built right into ductless units that provide some you know, virus killing effects.
Okay. Do all air source heat pump brands have the variable capacity that you spoke of?
All the ones that are on the NEEP list and are suitable for cold climates in the Northeast. You know, ductless heat pumps are incredibly popular worldwide, and I think there may be some units that are sold in other countries that don't have this inverter technology. All the ones I'm familiar with in our market have switched over to that variable speed inverter-driven approach.
Okay. Can you talk a little about the average winter COP you're seeing on your projects?
Yeah, so honestly, we're a small company, and we're contractors, not researchers. As much as I would like to do more research, we have not instrumented our systems to measure that average COP. Some of that work has been done, probably most notably by Stephen Winter Associates. If you Google, you know what? I'll provide a link in the notes. but they have an excellent study on cold climate performance of heat pumps. And what they found was that there were dramatic differences in efficiency from one install to another. And that a lot of this had to do with proper sizing of the system and proper occupant education. So the best systems were hitting that, COP of 2.9 and up, but there were some systems that were, either oversized or poorly controlled, that were, their COPs were down in the 1 to 2 range for the whole season, which, that's kind of miserable. And so, a lot of our learnings are focused on how can we avoid that outcome? How can we help them achieve their rated efficiency? They had to do some pretty interesting things to do this measurement. They had to have recording temperature monitors. They had to measure airflow through these systems with a duct blaster. It was pretty complicated setup they have. It's not something that can easily be done. That's one of the big advantages that Geo has, is that a lot of them now have this monitoring capability built right in.
Mm-hmm. Very good. Are assisted home performance program funds, AHP funds, available to be used for HVAC and specifically air source heat pumps?
Yeah, they've always been available for high efficiency furnaces and boilers, and NYSERDA has recently been allowing them to be used for air source heat pumps, which, something I argued very strongly for, both from an environmental perspective and an energy affordability perspective. While the fossil fuel equipment is on the pre-qualified list, the air source heat pumps are case by case. So you have to be prepared to make a case to the program administrators that it is going to save money and it is going to be a good choice for the homeowner.
Yes, very good. The DEC is starting to put out stronger regulations on larger refrigerant systems. I know you're a big fan of controlling refrigerant, and one question is asking for your ideas on how we can motivate installers to better recover and recycle or dispose of refrigerants properly. Generally, there's a cost to recover an old unit. There's no real financial benefit. What's your experience with that, John?
Yeah, so there's kind of two pieces to this. Because we are in a stage of rapidly scaling up this industry, we are putting in a lot more systems than we're servicing or taking offline. And so getting the refrigerant piping tight and well installed and preventing it from leaking right now is a big focus of some of the writing I'm doing. The keys there are, good technique with flaring your copper and thorough testing. Now, I think what the programs need to do is take better advantage of some of the tools that are available to document that the proper testing has been done. There are now apps that can document your pressure test, document your vacuum decay test, and download those graphs, which can be uploaded right to the the program. And so right now we're working with kind of on our system checklists on our refrigerant technique. I would like to see us move towards actually documenting what we're doing in a more robust way. Refrigerant recovery is it's so critical, and I think there needs to be more support. It's not easy to find places that will take your refrigerant. You typically do this through the supply house, but if you didn't buy their recovery canister, they don't want the one you're turning in. I would love to see some extra incentives from NYSERDA or the DEC for good refrigerant practices.
That would be great. Next question, interesting question. Do you think centrally ducted units that meet the heat load requirements qualify for New York State incentives might lead to mold issues in homes because cooling tends to be oversized for our climate? What do you think?
I think that's something we're going to have to keep an eye on. You know, one of the nice things about these variable speed systems is that a lot of them can modulate way down. And so, you know, a system might have a 3-ton capacity. It might modulate all the way down to 3/4 of a ton. And so the oversizing isn't necessarily as bad as it looks on paper because of that variable capacity. You know, I think we need to pay more attention to mold in buildings in general. And this is also part of where this whole house approach comes into play. You know, we need to be thinking about what are the sources. Do we have a dirt floor crawl space? Do we have, you know, poorly controlled water leakage in a basement? Do we have excess humidity that's generated by occupant behaviors? Do we have, you know, poorly designed attic ventilation? So if we can, you know, there's many ways that we can address this, but it absolutely needs to be on our radar.
Absolutely. Couple more questions. Do you have any idea how do-it-yourself heat pump pre-charged 410 systems can be sold without EPA 608 certification? Now there's a question for you.
No, I really have no idea. But yeah, you can go on eComfort and order your pre-charged system, and I fear for the worst.
Yeah, I have to admit, I didn't know you could do that. That sounds dangerous to me. Any particular manufacturers you favor and for air source heat pumps? And if so, why?
I think this is a great question, and I think it behooves me to be kind of neutral on this and to maybe speak more generally. I think there's a couple things that are important to me. One is the quality of the equipment. You know, as a contractor, nothing kills your profits like callbacks. And so having, you know, equipment that's manufactured by a company that's been doing this for a long time, that has, you know, tight quality standards, and has a, you know, a long history of, you know, parts availability and so on. That to me is absolutely critical. And then the other thing that's big for me is technical support. I don't want to call a phone number and be stuck on a, you know, on hold for 45 minutes while I'm standing up on a ladder waiting to, you know, measure the voltage on a control board. You know, I want to have a local rep who I can get right on the phone with and who can talk me through, you know, the problem I'm experiencing. I would say that if people want to ask me some more specific questions, go ahead and send me an email.
Okay, very good. Yes, and that's a good kind of a segue into the ending of this webinar, because it is 5:59, and I like to start exactly on time. I like to end exactly on time. That's just something I like to do. So we want to thank you, Jon, for this, for your time today. We want to thank all the attendees for coming. I encourage you all to register for the last webinar in the series. If you have not already registered, and if you're an installer, feel free to register for the August 22nd event, because I think that'll be very beneficial. It has been suggested that there are still a couple of questions out there, and if that's the case, we'll respond via email, but I can't find them. I think we've dealt with all the questions. but we'll send you an email if we haven't. And feel free to reach out whenever necessary. Thank you again, Jon. Conrad Metcalfe signing off.